All right, hello guys, it's Miss Beckham again. Today we are going to go over the metric system and unit conversions. So to start, there are two main different systems that the world kind of uses for units. What we use in the US is called the imperial system. So that includes yards, feet, inches, Fahrenheit, ounces, gallons, pints. But that's not actually the system that most people in the world use it. What internationally everyone uses is typically the metric system. And so in this class, we're going to be using the metric system. So there are four different kind of categories in which we have different units for. The first category is length. And for length, we use the meter. We abbreviate it M. For mass, we use the gram. For volume, we use the liter. And for time, we use the second. So you guys are probably familiar with a meter, a gram, a liter, and a second, all of those things. What we do is these are our base units, the meter, gram, liter, and second. Now we can add on prefixes to those units. Okay, so it's important to understand what these prefixes mean and how they relate to their original units. So let's say that we have, let's look at this prefix milli right here. So milli can be tagged on to any of these base units. You can have a millimeter, a milligram, a milliliter, and a millisecond. Let's look at a milliliter. So what this chart is saying, so I'm going to underline it right here and go across, right? 1 millimeter or millisecond or anything. I'm just using millimeter in this case. 1 millimeter is equal to 10 to the negative 3 meters, okay? So this magnitude right here relates this prefix to the base unit. So let's look at a centimeter. 1 centimeter is equal to 10 to the negative 2 meters. And also right here it shows you whenever you plug into the negative 2, that's 0.01, 10 to the negative 3 is 0.001. But what's really important is that you understand how these relate. So let's look at a kilosecond. So kilo is right here, and we can add this to any of these original four base units. So 1 kilosecond is equal to 10 to the 3 seconds. So to put that in reverse order, you can also say 10 to the 3 seconds is equal to 1 kilosecond, right? You could say it either way. You could flip it around on either side here. Knowing how to use this comes into play for conversions. And so what's next, I've kind of added in my slide. You'll see that there are two different slides, one that says RB, dimensional analysis, and I put in this slide because I think it's important. You can memorize this mnemonic. Like kittens is for kilo, hate is hecto, which we don't have right there, dogs is for deci, but do chase, centi, and then mice for milli if you want to try to, because you will need to know these. You have to have these memorized, this relationship memorized. Next here we have conversion factors. And so a conversion factor is basically a ratio that you can use to convert from one unit to another. So for example, for this problem here, if you have $12 and you want to know how many quarters you have, you know the relationship between quarters and dollars is that there are 4 quarters, that 4 quarters equals $1, right? 4 quarters equals $1. You could also say that there are 4 quarters for every $1. That's supposed to be a Q right there. Or you could say that there's $1 for every 4 quarters. Both of these statements are true. They both come from this because it's a ratio. 4 quarters to $1 or $1 to 4 quarters. It's the same thing. So if we're trying to get from dollars to quarters, someone says, how many quarters are in $12? You always write down what you start with. And we're trying to figure out how many quarters there are. So that means that quarters needs to be on top. We also know that we need dollars to cancel out. So dollars needs to be on bottom. So the ratio that we use, these are both the same thing, but we have to put in the correct format here. So because we want quarters on top, we need to use this one. So there's 4 quarters for every $1. That way our dollars can cancel out when we multiply. Then we've got 12 times 4, which, correct me if I'm wrong, is 48 quarters. That's how many quarters you have. So when we apply this to our prefixes, okay, so from our prefix chart right here, we see that centa means 10 to the negative 2. So if you remember from math, 10 to the negative 2 is the same as saying 1 over 10 squared, right? The negative means it goes on bottom, which is 1 over 100. So from our SI chart, we know that it's 10 to the negative 2, which is 1/100th. That means that for every 1 meter, there is 100 centimeters, right? We could also phrase this differently. We could say that for every, if we go back up to our prefix chart, it's 10 to the 1 centimeter is 10 to the negative 2. So that means that for every 1 centimeter, there's 10 to the negative 2 or 0.01 meters. So for every 0.01 meters, we have 1 centimeter. That's just a different way of saying it. So now that we kind of see those relationships here, let's try to convert between grams, decigrams, centigrams, and milligrams here. So we always write down what we start with, which is 1 gram, right? Now this problem is having us convert to decigrams, which means that we need decigrams on top and grams on bottom to get grams to cancel out. So let's go up and look at the relationship we see here. And we see here that for a decigram, there are 10 to the negative 1 grams in 1 decigram. So we put 10 to the negative 1 on the bottom because there's 10 to the negative 1 grams in every 1 decigram. When we compute that, we should get the number 10 decigrams, right? All right, now let's convert from grams to centigrams. So 1 gram times, and we want centigrams on top now, and we want grams to cancel out. So we need the relationship between these two. And we know that there are 10 to the negative 2 grams in 1 centigram. 10 to the negative 2 grams for every 1 centigram. So when we calculate that in our calculator, the grams will cancel out, and that should get us 100. Okay, now let's convert from grams to milligrams. 1 gram, right, and we're trying to get to milligrams now. So if we look up here, we see that there is 10 to the negative 3 grams for every 1 milligram, or 0.001. You can write either of these because when you compute it, it's the same thing. So 10 to the negative 3 goes on bottom for every 1 milligram. Okay, and so this will cancel out, and that will leave us with 1,000 milligrams. There are 1,000 milligrams in every 1 gram, right? And so the next question, 1,000 grams equals how many kilograms? So you always write down what you start with, and we're trying to get to kilograms now. So what's the relationship between kilograms and grams? When you look at this chart, there are 10 to the positive 3 grams for every 1 kilogram. 10 to the positive 3 grams for every 1 kilogram. When we compute 10 cubed, the grams cancel out, and 10 cubed is 1,000, right? So 1,000 divided by 1,000, we've just got 1 kilogram as our final answer. I should be filling these in. This should be 1, 10, 100, and 1,000. So I'm going to have y'all try these and let me know if you have any questions on those. And here's again some more practice problems for you guys. Yeah, so let me know if you have any questions.